Good day, viewers. Welcome back to our chemistry class. Today's class is going to be based on writing and balancing of chemical equations. Just before we proceed into this topic, if you have not subscribed to this channel, kindly do so and click the notification bell for my subsequent classes. As we all know that this topic is one of the vital topics in chemistry that everybody must understand. Now, when we're talking about chemical equations, these are shorthand ways of writing chemical formulae in order to show the substances that are changing, the chemical changes or the physical changes. Those substances that are changing or that are disappearing are referred to as reactants, while the substances that are appearing or showing they are referred to as the products. Now, when we have reactants, it gives products. So this left hand side are the reactants. So they are the substances disappearing or undergoing the changes. Then we have the products, which is the substance that is appearing or was changed. Now, this arrow here means yield. It can mean produce. It can also mean given off in terms of when it is gases. Now, let's look at the simple rules that guide the balancing of chemical equation. The first rule is to write the chemical elements correctly as they occur naturally. As an example, the group 8 elements must be written using their correct elements, like helium as He, neon Ne, argon Ar. Likewise, the group 7 element, they are diatomic elements, talking about nitrogen, talking about fluorine, talking about iodine, bromine, and so on. So you must write them very well. So you don't write hydrogen as ordinary H. It should be written as H2. Secondly, do not change the subscript of the chemical elements. Like normally, argon is Ar. And I want to balance argon. You now write a number here, 2. It is not done. The natural element is Ar and the subscript is just 1, so you don't change it. Unlike Br2, bromine, the subscript is 2. You don't change it and put 3. So do not change the subscript. And finally, balance both the left and right substances with numbers greater than 1. So we start balancing from number 2, 3, 4, and so on. Now, and those numbers must be written as coefficients, meaning it should be balanced before the chemical compound. It should be written before the chemical compounds. Now, to balance chemical equations, we normally use two methods. The first one is inspection method, and the second one is simultaneous equation method. In this lesson, we are going to be looking at the inspection method. So, let's dive in. Example 1. Write and balance the following chemical equations. We have to go on. Sodium combining with hydrochloric acid. So what is going to be given? Now, here we have to dissociate this and put it into ions. Let's have sodium. The charge of sodium is +1 as we have length in valency. Then HCl will be broken up into H. The charge of hydrogen is +1. Then we have chlorine, Cl, and the charge of chlorine is -1. So the next thing is the positive charge will attract the negative charge. As a rule in science that says like charges repel, unlike charges attract. Positive and negative will attract each other. meaning that sodium will come and mate with chlorine. Then what are we going to have? If you could recall, when we are writing our chemical compounds, sodium is meeting with chlorine. Sodium is having +1. Don't forget, we are going to leave that positive sign, while chlorine is having 1. If you are not clear about this, you can quickly go into the writing of chemical formula that we have done in this class. Now, the next thing is you cross multiply. This one will come here. We are going to positive first, Na. So 1 is coming, then Cl, 1 is coming. So this one will be NaCl. So this thing now, we have NaCl, Na1, Cl1, plus then hydrogen. Don't forget, hydrogen is diatomic gas, as we have learnt. So H2. Meaning that when sodium reacts with hydrochloric acid, it's going to form NaCl plus hydrogen. So this is the product formed when these two substances react. The next thing is, how do we balance these chemical equations? Using expansion method. We have Na. In this equation, we have Na, that is sodium. We have H, then we have Cl. That is for the left hand side, which is the reactant. The same thing will be gotten from this right hand side: sodium, hydrogen, and chlorine. Now let us now look at this. How many sodium do we have here? When we look at it, this is 1 sodium. How many hydrogen do we have here? We have 1 hydrogen. How many chlorine do we have here? We have 1 chlorine. We come to the right hand side as well. How many sodium do we have here? We have 1. How many hydrogen? We have 2. How many chlorine? We have 1. So when we look at this, you can see that there is a difference between hydrogen here and hydrogen here. So I have to make sure this hydrogen becomes 2 as this. Coming to this equation, we have hydrogen here. So I have to balance this with 2 here. If I put 2 here, hydrogen has changed to 2. Likewise, chlorine has changed to 2 because this 2 is for everything now. It is before the 2 elements. So chlorine has changed to 2. Now, since chlorine has changed to 2, come here, we have to change this chlorine to 2. And we have chlorine here. Definitely, to balance, don't forget our rule. You must not change the subscripts. You can only add number here. So let me put 2 here. If I put 2 here, my chlorine has changed to 2. But something has happened here. My sodium also has become 2. Now come here, my sodium is 1. To make this sodium 2, I have to put 2 here. So 2. Now here we have 2 sodium, 2 sodium, 2 hydrogen, 2 hydrogen, 2 chlorine, then 2 chlorine. Is balanced. Next question. Calcium is reacting with water. So we want to look at the products that will be formed here. Now, let's look at it. Calcium. What's the charge on calcium as we've learned? It is 2 plus, that's plus 2. Then plus water. When we are trying to dissociate water, water is to be dissociated into hydrogen and OH. So hydrogen, what is the charge of hydrogen? Is plus. Then OH, according to our what we learned in our radical, is minus. Now, positive will mate with negative. Now, for positive to mate with negative, we have calcium, Ca, having 2. Then we have OH, having 1. So cross multiply. Then we have Ca, 1 is coming here. OH, 2 is coming here. So when I put it like this, it means my hydrogen is having that 2. So I have to open bracket and close the bracket. So I have Ca, OH, bracket 2, then plus it remains hydrogen. And hydrogen must be written as diatomic gas. So H2. So when calcium reacts with water, it's going to give us calcium hydroxide plus hydrogen gas. Now, let us balance. Now, we have from the left hand side, we have calcium, we have hydrogen, we have oxygen. Likewise, here we have calcium, we have hydrogen, we have oxygen. Now, let's look at this. How many calcium do we have here? We have 1 calcium. How many hydrogen do we have here? This hydrogen owns this 2. We have 2 hydrogen. How many oxygen? We have 1 oxygen. Now, let's come here. How many calcium? We have 1. How many hydrogen do we have here? Here we have, these 2 is for everything inside this bracket. So we have 2 hydrogen here, then we have 2 hydrogen here. So 2 plus 2, we have 4. Then how many oxygen do we have here? We have 2 oxygen. Now something has changed. Here, hydrogen is 2 here, hydrogen is 4 here. I have to make this hydrogen 4. Let me put 2 here. My hydrogen has changed to 4 now. Now it's balanced, But oxygen, there's a deficiency here. Oxygen here is 2. Then how many oxygen do we have here? So this 2 is for everything. Oxygen also is 2. So it's balanced. So 1 calcium, 2 times 2, 4 hydrogen, 2 hydrogen here plus this 2 making 4. This 2 is also for everything. So 2 for oxygen, 2 for oxygen. So this one also is balanced. Next question. Sodium hydroxide reacts with tetraoxosulfate of a cis acid. What is going to form here? Now, let us dissociate this as well. We have sodium with a charge of positive, as we all know, plus 1. Then we have OH with a charge of negative, that is minus. Then we now move on to the next one, plus. Now to dissociate these 2 we have to move forward. I have 2H. So the charge of hydrogen is plus. Then we have SO4. The charge of this sulfate is 2 minus. Now, positive have to combine with negative. Sodium, we have to combine with sulfates. OH minus have to combine with H plus. Now, we now come here. Na is having plus, that is 1. Then SO4 is having 2 minus, that is 2. We have to cross multiply. So we have Na2 SO4 1. So when you open bracket and close the bracket, 1 times 4 still remain 4. So we are going to have Na2 SO4 bracket 1. Now it remain OH minus and H plus. So H plus, that is 1. OH, that is also 1. So OH1, then H1. So cross multiply, we are going to have H1 and OH1. So when I look at this, how many hydrogen do we have here? We have 2. H2, then 1 oxygen, O. H2O. Definitely, when sodium hydroxide reacts with H2SO4, we are going to have Na2SO4 plus H2O. Now, let us balance this equation. We have the elements here, Na, we have oxygen, we have hydrogen, then once again we have sulfur. Likewise, in the right hand side, we're going to have sodium, oxygen, hydrogen, and sulfur. We now say, how many sodium do we have here? We have 1 sodium here. There is no sodium here. 1. How many oxygen do we have here? We have 1 here. How many here? We have 4. 4 plus 1, we have 5. How many hydrogen do we have here? We have 1 hydrogen. How many here? We have 2. 2 plus 1, we have 3. How many sulfur? We have 1 sulfur. Move to the right hand side. How many sodium? We have 2 sodium. Oxygen here we have 4. Plus this one making 5. Hydrogen here we have 2. Then sulfur we have 1. Now a lot of changes has come here. Now we have to do what? We have to find a way of balancing it using this inspection method. 1 sodium, 2 sodium. I want to make sure this one becomes 2. Let me put 2 here. My sodium has become 2. My oxygen here is 2. Oxygen here is 4. 4 plus 2. Oxygen now becomes 6. Now, let's look at oxygen here. 4 here, 1, still making 5. Let me put 2 here. So 2 here plus 2 making, that is 2 oxygen plus 4 oxygen making 6. Hydrogen. Hydrogen here is 3. Hydrogen here is 2. But something has changed with hydrogen as well. This 2 is affecting hydrogen. Hydrogen becomes 2 here. Hydrogen here is 2. 2 plus this 2, making 4. Let's look at this. Hydrogen here, 2 times 2, making 4. Now, how many sulfur? 1 sulfur. How many sulfur? 1 sulfur. So this equation is also balanced. This is an inspection method. Example 2. Write and balance the following chemical equations. Calcium triisocarbonate 4. When we eat it, what are we going to have? Let's associate this. We're going to have the positive and the negative side of it. Calcium having a charge of 2 plus, then we now have CO3 2 minus. But here, CO3 cannot form at the product. What we're going to do is that we're going to break down this further. So we have Ca2 plus, a gas will be coming out from here, CO2. Then when we remove CO2, it's remain one oxygen, O. That oxygen is having this charge of 2 minus. Now, in this case, the product formed now is going to be calcium will move join with oxygen. When calcium joins with oxygen, don't forget here, calcium is having a charge of 2 plus, that is 2. Then oxygen having 2, cross multiply. So we have Ca2O2. Since the two are the same, they cancel each other. We have CaO. So definitely we have CaO plus carbon 4 oxide, CO2. So when you eat calcium triisocarbonate 4, it's going to give CaO plus CO2. Now let us list the elements that we have on the left and right hand side. Calcium, carbon, and oxygen. Calcium, carbon, and oxygen. So how many calcium do we have here? We have 1. Carbon, we have 1. Oxygen, we have 3. Calcium here, we have 1. Carbon here, we have 1. Oxygen here is 1. Plus these two making what? 3. So this is balanced already. Second example, aluminum chloride reacting with H2O. Let us break this down. Aluminum chloride, Al. The charge of aluminum, as we know, the valency is 3 plus. Then chlorine. To write this chlorine, these 3 will move forward. We have 3 Cl. Then charge of chlorine is minus 1. Then plus, water will be split into H plus and then OH minus. Now, the positive charge meets with the negative charge. So we are going to have Al first. This one will come here, 1. Then OH. Then this 3 is coming. So open and close. Don't forget what we used to do. Al, it's having 3. Then OH is having minus 1, that is 1. Cross multiply. So we have Al1, OH3. So you have to open back and close it here. Now, secondly, chlorine wants to meet with hydrogen. Hydrogen having 1, chlorine having 1. So if you cross multiply, you are going to have what? HCl. So which means when aluminum chloride reacts with water, we are going to have aluminium hydroxide plus HCl. Now, let us now balance it. We have the elements here, Al, aluminium, chlorine, hydrogen, oxygen, aluminium, chlorine, hydrogen, oxygen. So how many aluminium do we have here? We have 1. How many chlorine? We have 3. Hydrogen, 2. Oxygen, 1. Now come here. Aluminium, 1. Chlorine, 1. Hydrogen here is having 3. The oxygen here is having 3. So what changes here? Chlorine is different here. We have 3 here, we have 1 here. So to make this one 3, let us put 3 here. When the chlorine changes to 3, hydrogen has changed there already. Hydrogen here is 3. Hydrogen here is 3. So 3 plus 3, making 6. So the hydrogen here is 6. But the hydrogen here is still remain 2. Let me put 3 here. 3 times 2, we have 6. Now oxygen here is 1, oxygen here is 3. How many oxygen do we have now? Here is 3. And here also oxygen is still remain 3. So this equation is also balanced. So this is the method of inspection. So, but in the exam, we don't need to show this. We don't need to show it. All what we need to do is we do it in a rough sketch and also just balance our equation direct. Don't forget, I remain Latif Ismaila Akambi, your mathematics and chemistry tutor. If you have not subscribed before on to this channel, kindly do so and click the notification bell for my subsequent content.